Okay, we can begin. All right, so here are the questions. We'll start with the first one. It says, assume that you have a 5,000 you want to have a 5,000 in 2 years' time, and the nominal interest rate is 25%. How much do you need to invest now to produce a 5,000 in 2 years' time? So here basically, before I answer, maybe let me ask you, what are we trying to find here? What's the question asking us to find? Here, we want to have a 5,000 in 2 years' time. So this is our future value. The interest rate is 25%. So we've got our R. So basically here, we're trying to find the present value. Basically, how much you need to invest today so that you get 5,000 in 2 years' time. So the formula for the present value is present value equals future value 1 plus R the power negative t. Our future value, this 5,000 we want to have in 2 years' time. Our rate, 25%. So the rate always convert it into a decimal. Our time is 2 years. So 5,000 multiplied by 1.25 to the power negative 2. At our calculators, 1.25 to the power negative 2. That is 0.64. Okay, 1.25 to the power negative 2, that is 0.64. 0.64 times 5,000, you get 3,200 kwacha. Okay, 3,200 kwacha. So this is how much you need to invest today. Okay, then if you're earning interest of 25%, in 2 years' time, this 3,200 will become a 5,000. Any questions? Any questions before we go to the next one? Okay, we can go to the next one. It says, assume you want to have a 2,000 kwacha in 3 years' time, and the nominal interest rate is 21%, and the annual rate of inflation is 10%. How much do you need to invest now to produce 2,000 kwacha in 3 years' time? Okay, so here, now we've brought in the inflation. Okay, so remember, inflation not only does it erode the purchasing power of money, but it also lowers your interest, the interest that you'll be receiving. Okay, so when you take into account inflation, what the interest that you're going to be getting is going to actually reduce. All right. So the first thing, whenever you hear inflation in these questions, you need to find the real interest rate. Colleagues, do you remember what real interest rate means? What's the definition of the real interest rate? You've got the nominal interest rate and you've got the real interest rate. Do we remember the definitions? Let me just get this formula here. So the real interest rate is the interest rate that is adjusted for inflation. Okay, colleagues? The interest rate that is adjusted for inflation. Okay. So there is this formula you can use, okay, to get the real interest rate. 1 plus the real interest rate equals 1 plus the nominal interest rate over 1 plus the inflation rate. Now, if you forget this formula, let's say it's an exam and you forget this formula, you can always use this simple one. The real interest rate, RI, is the nominal interest rate, NI, minus the inflation rate. Okay? You get similar, this formula here is more accurate, but you get similar figures. Okay? But usually in questions, the lecturer will expect you to use this formula here. Okay, this 1 plus real interest rate equals 1 plus nominal interest rate, 1 plus the inflation rate. Okay, so first things first, we need to find the real interest rate, the interest rate that is adjusted for inflation, or you can think of it as the interest rate that takes into account inflation. The nominal interest rate doesn't take into account inflation. It's just your overall interest rate. Okay. So here you say 1 plus the real interest rate, 1 plus RR equals 1 plus the nominal interest rate. In this question here, they told us the nominal interest rate is 21%. So you can get, you say 0.21 divided by 1 plus the inflation rate. The inflation rate in this question here is 10%, so you're going to say 0.1. Okay, so 1 plus 0.21, 1.21, divided by 1 plus 0.1, 1.1. This side we have 1 plus the RR, the real interest rate. Okay, so we divide 1.21 divided by 1.1. You're going to get 1.1. Okay, then here we have 1 plus our real interest rate. So to get our real interest rate, this 1 is going to cross over the equal sign. So it becomes 1.1 minus 1. Okay. So 1.1 minus 1, that is 0.1. 0.1 converted into a percentage, that is 10%. That is 10%. So when we take into account inflation, all right, the interest that we're getting, okay, is 10%. Not this 21%. This 21% we never accounted for inflation. When we account for inflation, the interest that we're getting in actuality is 10%. Any questions before I move further? Any questions, queries? Okay. So now we've got our real interest rate. Now we can find out how much we need to invest to have a 2000 in 3 years' time. Okay. Again, this question, we want to find out how much we need to invest today so that we get a 2000 kwacha in 3 years' time. So again, we're using the present value formula. Okay, present value PV equals the future value open brackets 1 plus R to the power negative T. The future value, we want to have a 2000 in 3 years' time. So this is the 2000 here. Our rate, okay, we're not going to use the 21%. We're using the real interest rate, which is 10%. 10% in decimal form is 0.1. The power negative 3. Okay, because we want to have this 2000 in 3 years' time. Okay. So it is going to be 2000. 1 plus 0.1, that is 1.1 to the power negative 3. 1.1 to the power negative 3 is 0.751. Yes, is that a question? Oh, okay. You can answer, okay? Whenever you get the answer, just you can say, you can just shout out the answer, okay? Yeah, feel free to shout out the answer. Okay, so when we multiply 2000 times 0.75, what do we get? 1500. Yes, 1502 kwacha and 502 point. Since there's some decimals, always leave to two decimal places because in Ngwes they're up to two decimal places. Okay, so 1502 kwacha 63 Ngwe, right? Yes. Any questions? So in reality, when you're making decisions with these type of questions, it's always important to take into account inflation, because if you ignore inflation, yes, you know how much you need to put and everything, but since there's some inflation in there, it's not really what you're getting in actuality. Okay, so it's always important to take into account inflation. I believe you have all done macroeconomics, right? Where the topic of inflation and real interest rates. Okay, we've got the next question here. Mhm. Yes, yes, because this 2000, there is no operation going on with it. So you have to start with this 1.1 to the power negative 3 so that you get your value. Yes. Now, as I say, this topic is a very practical topic. Okay. Just the way we're finding out the answers for these questions, even businesses, okay, they can find out, okay, if we invest our money here, where there will be any an interest here, how much are we going to have after this number of years? How much do we need to put in? Okay. This also helps businesses with planning, okay? Planning and making decisions. All right. So now the next one. Assuming you want to buy home furniture costing 27,500 and the supplier has given you two payment options plans. Option 1 requires you pay the entire amount now, and option 2 entering into an installment plan where you pay 2,000 kwacha down payment today and you make payments of 9,500 in each of the next 2 years. Assume the interest rate you can earn on safe investments is 20.8%. Which option is cheap? Okay. So here we're now comparing options. Okay. You can either pay this 27,500 just now, you get your furniture, or there's the installment plan. So the way we're going to compare these options is through the present value basis. Okay. So for option 1, the present value is 27,500. That's how much you're paying. Now for option 2, we pay 27,500. Okay. Now for option 2, okay, we have to find the present value of these 9,500 which you pay in year 1 and the other one you pay in year 2. Okay. This 12,000 you're paying it today. Okay. So for option 2, let's get our present values. Okay. You've got the 12,000 that you pay upfront, plus, remember we're still using the present value formula, future value multiplied by 1 plus r to the power negative t. In this case, this 9,500, you take it as a future value. You say 9,500, open brackets, 1 plus our rate, 20.8%, so that is 0.208 to the power negative 1. Since this 9,500, we're paying it in the first year, plus in year 2, we're paying another 9,500. We have to convert it into today's value. 1 plus 0.208 to the power negative 2. Since we are paying this in this, the other 9,500, we are paying it in the second year. Okay. So let's do our tabulations. So 1.208 to the power negative 1. What do we get? Let's get our calculators. 1.208 to the power negative 1. What value do we get? Yes, colleagues, 1.208 to the power negative 1. Are we getting 0.827? So here we write 12,000 plus. First, we're starting with the power negative 1. I'm getting 0.827. Okay. You can just leave it in 3 decimal places or even 2. Plus 9,500 multiplied by 1.208 to the power negative 2. We get 0.685. So multiply. Just hold on. 9,500 times 0.827. We get 7,856.5. Okay, so this 9,500 which we're going to pay in the next year, today its value is 7,856.5 plus 9,500 multiplied by 0.685, 6,507.5. So the 9,500 which we're going to pay in year two, today's value is 6,507.5. Okay, so we just add this 6,507.5 plus 7,856.5 plus 12,000. We get 26,364. So we weigh the options. Option one, where you pay the full amount, 27,500. Option two, where you pay the 12,000 now, then 9,595 in consecutive years. When you put it in a present value basis, it's 26,364. So, colleagues, which option should we go with? I believe everyone would say option two. Any questions? So, whenever you're given these type of questions where you have to compare, all right, just know you're comparing it on a present value basis. Okay. Oh, it's here. It's in the question here. Assuming you want to buy home furniture costing 27,500. Yes. Any questions before we go to the last and final question for today's lesson? Okay. Find the future value of an annuity for 2,500 paid at the end of each year for 3 years, assuming interest is compounded at 26%. I'll do this first part. When we end the class, you do the second part in your spare time. Colleagues, what is an annuity? What is an annuity? Is anybody a landlord here? Does anyone get a salary here? Those are two examples of annuities. An annuity, okay, it's the same amount being paid to you over the same period of time, okay? For example, like your salary, if your salary is 10,000, at the end of the month, you get paid 10,000. The next month again, you get paid 10,000. The other month, 10,000. And until the whole year passes, you've just been getting 10,000, 10,000, 10,000, 10,000, 10,000. So an annuity is just where you're getting the same amount of money over the same time period. Okay. If you're getting paid per year, let's say you're getting paid 30,000 per year. Next year, another 30,000. The other year, another 30,000. That is also an annuity. Are we okay with that, Madam Angela, Madam Besta, Madam Karen? All right. Now, there are two types of annuities. There's an ordinary annuity and there is an annuity due. What is the difference between the two? What is the difference between an ordinary annuity and an annuity due? An ordinary annuity is paid at the end of the period. If it's at the end of the month, at the end of the year, that's an ordinary annuity where you're paid at the end of the period. Annuity due is where you're paid at the beginning. At the beginning. Oh, that's not how you spell beginning. At the beginning. Okay. If you're paid at the beginning of the month, beginning of the year, beginning of the quarter, that's an annuity due. Okay. So just remember ordinary end, due beginning. Okay. I believe most of you are paid at the end of the month. So just remember ordinary annuity, what I'm getting paid at the end of the month. Annuity due. If you're paid at the beginning, then you can use those as a guideline to remember. Okay. So in this equation here, this is the equal payments that you'll be receiving. Okay. In this question here, they told us where you're receiving 2,500 paid at the end of each year for 3 years. So since they've told us paid at the end, so the question won't tell you if it's an ordinary or an annuity due. It's you to read. So when you hear at the end, just equate it to an ordinary annuity. Okay. And the interest is compounded annually at 26%. Okay. So whenever there is a compounding in the question, this is always what you have to do. Okay. Whenever there is a compounding, always divide the rate by the number of compoundings and the time multiplied by the number of compoundings. Okay. In any of these questions, if you just hear there's compounding to the power t times n, just divide the number of compoundings by the rate and multiply the number of compoundings by the number of compoundings by the time. Now here it's compounded annually. Okay. So what does n equal when interest is compounded annually? What does n equal to? Because you have to know when it's compounded annually, semi-annually, quarterly, monthly. You have to know. Okay. Always remember, we're always referencing a year. So annually, n is 1. If it's semi-annually, that means n is 2. It means you get paid twice. Okay. If it's quarterly, n is 4. Okay, because remember in a year there are 4 quarters. If it's monthly, n is 12. In a year there are 12 months. If it's daily, n is 365 because there are 365 days in a year. Okay, colleagues, just remember you're always referencing a year for the number of compoundings. So in this question here, it's compounded annually, so n equals 1. So really, our rate won't really change because if you divide your rate by 1, it's still the same rate. And also the time, if you multiply it by 1, it will still stay the same. Okay, so really won't have any changes here. Okay, but actually, I don't know why I even removed that. To get full marks in this type of question, you need to show this. Okay, so we're being paid 2,500 at the end of each year. That is our A. Okay, this is the amount which are being paid at the end of each year. Open brackets. So here we say 1 plus the rate. I think it was 26%, if I'm not mistaken. 26%. Okay, so we're going to say 0.26. Since the number of compoundings is 1, so it says 0.26 divided by 1, you still get 0.26. To the power, okay, since they said 3 years in the question, okay, it told us either the end of each year for 3 years. So here, this is the time here, 3 years. So 3 multiplied, remember the time you multiply by the number of compoundings, 3 times 1, that is 3. Minus 1 divided by the rate 0.26 here. So let us solve. 1.26 to the power 3. What do we get, colleagues, when you say 1.26 to the power 3? 2.003. Okay, we can just leave it as 2 then. Okay, let's just 2.000. We add the other 0 and the 3 thing. Minus 1 divided by 0.26. So 2.003 minus 1, then divided by 0.26, what do we get? So 2.003 minus 1, that's 1.003. 1.003 divided by 0.26, you get 3.84. Are we all getting 3.84? Okay, so 2,500 minus 3.84. Yes, madam, you can round off. Okay, you can round off. Feel free to round off. Okay, yeah, and we saw there was a 847. Just wanted to put it in. So again, I put 3.85. Okay, so let's just use 3.84 for this case. So 3.84 times 2,500, 9,600. Okay, any questions? Wonderful.